Okay, so the last topic in this chapter is velocity time graphs. So again, remember we looked at position time graphs in the last section, and you worked your way through the MOPAPs. And we've already done velocity time graphs when we did the summary sheets, and we looked at the data for the describing motion with numerical tables of data. So now we're just going to kind of condense it all together on these last couple doodle note sheets. So you should be on page, I think it's 19 in your green packet. And remember, there's nothing new here, okay? This is all stuff we've been doing. So very much like the position time graphs that we did previously, you should be able to do a lot of this page without any assistance from me. So first of all, I want to know this area that's down here that's got this big green X through it. We're not going to do that part. We're not doing areas under the curve, not needed to do in this section. So the top part here says read the graph to find the velocity. And so it asks you the velocity at a number of different time intervals, and you can just read that information off the graph. So this is velocity versus time. So at 5 seconds, you can come over to 5 and you can read what the number is and write it down. Be sure you include your units and your direction. And then they ask you, what is the maximum velocity and when does it occur? Maximum velocity is going to be the biggest number here for the velocity, so you should be able to do that. So the time interval that has the greatest acceleration, and they ask you to calculate that acceleration for that time interval. So the greatest acceleration is the part that has the largest slope, or which one is the steepest line. Now, you might be able to eyeball it, and if you can, great. And if you can't, you can do the couple of calculations to do it. But remember, to calculate acceleration, you're going to use the final velocity minus the initial velocity divided by the total time interval for that velocity. So you have 3 different sections here, and you can probably look at them and determine which one actually has the largest acceleration. But pause the video and go through and record all these numbers and record the information. So here are the answers to this section. So at 5 seconds, they recorded 25 meters per second north. 7 seconds also was 25 meters per second north. 15 seconds, 35 meters per second north, and 25 seconds, 25 meters per second north. The maximum velocity was at 40 meters per second north, and that's between about 17.5 and 20 seconds. And the steepest slope here, they believed that it occurred here between 0 and 5 seconds. So when they took and subtracted the final velocity minus the initial velocity, 25 minus 0, and it was for a total time of 5 seconds. 25 divided by 5 is 5, so they got 5 meters per second squared, and it is to the north. And again, we are not doing this part, and you don't need to do the shading in because the shading in has to do with this part here. So the only other thing that they wrote over here about is that the slope on a velocity time graph is the acceleration. And when we're here in this first quadrant, meaning that we're in positive velocities, positive slope means speeding up and negative slope means slowing down. Slope is rise over 1 or change in y over change in x. So that's velocity time graphs, the first page. So for the second page, on page 20, we've got something very similar to what we did in the position time graphs. And again, we're not concerned about the story. And before we look at the graph, what can we say about it? So there's a few linear segments, okay? And some are horizontal, some are sloped. And for anything that is horizontal, okay, what can we say about the velocity? So take a look at this one. This one here, the velocity is 0, and then later on it's 0. and then later on it's 0. So what does that tell you about the motion of the object? Hopefully you remember that it means that it's at rest. For one that's up here, the velocity is 20, and then later on it's 20, and then later on it's 20. It's also, now it's at constant speed. It's no longer at rest. Okay, it's only at rest when the velocity is 0. So let's take a look at the answer key. So here we go. We can separate our curve into a bunch of segments. So this initial one, it's at rest. The velocity is 0, and it's a horizontal line. And in addition, the acceleration is 0 because it's not moving. This next segment, we read off some of the velocities here and just wrote those down. Accelerating because the velocity is getting faster and faster and faster. So it's going from 0 to 10 to 20. So that's definitely speeding up. It's in the positive direction. It's a positive slope. So the acceleration is positive. You could actually calculate it here by taking the change in the velocity at 20 meters per second minus 0 divided by the time interval. This would be 2 seconds. This one would be 4 seconds. So we just have an example here of that. The next section is also a horizontal line. This is a constant velocity. So you read the velocity on the graph. This is 20 meters per second north. And you should put the north here. This one is also an acceleration. It's not constant velocity. It is slowing down, though, because it's going from 20 meters per second north down to 0. It's got a negative slope, so the acceleration is negative, and it's moving in the negative direction. So the next segment is a horizontal line, which means constant velocity. This constant velocity happens to be at a velocity of 0, so it's at rest. So the acceleration is also 0. And in this last segment, we've got a straight line. It's accelerating. In this time, the velocity is changing from 0 to minus 20. And so that means that it's speeding up, but it's heading in the negative direction. So the slope here is negative. And that tells us that this is heading in the negative direction. So we could calculate our acceleration here. And for this, we should also have a direction here. So this would be negative north, which would be positive south. So for our directions for each of these, this acceleration would be north. This one, the velocities would be all north, and then here we've got this being negative north, which means south. So each of our segments represent something different with the velocity time graphs. So now it's your turn to practice. These are challenging just like the MOP apps. Take your time, use your resources, don't rush. So we've got KG5, KG6, and KG7. Work on them slowly. Send me questions when you get stuck. Here are some additional resources on Physics Classroom about velocity time graphs. And again, good luck, and don't hesitate to send me any questions that you have.